All right, if you turn to page 13 is what we have called a factoring web or a factoring flowchart. And the factoring flowchart just helps you, as we get into more types of factoring, it kind of helps your thought process. Eventually we're going to solve quadratics, which that'll be the next chapter. So for right now, where it says look for a GCF, just make a little note here. And this is what we're going to be in for this chapter. Like a star, it says start here when only factoring. Because right now we're going to only factor. We're not solving. So, with that being said, we're looking for a GCF first at all times. And our options are either 2 terms or 3 terms. So if we think about what we've done already, the first lesson was looking for the GCF. We said we always do that first, which is what we have. Yeah, last lesson, we said if there's 2 terms, we would go over here. Here's 2 terms. And our options were, if those both were perfect squares and they were being subtracted, we could factor that with difference of squares. The other option is if it's not 2 perfect squares being subtracted, then you can't factor it any further. Today we're going to look at what happens if we have 3 terms. Okay, so keep this page 13 off to the side. This is going to be a good roadmap for you. So for this section, this is on page 5, we're going to factor this by unfoiling, or what I call the SAM method. All right, so what we know is that if we have x plus 2 times x plus 3, we could FOIL this and get x squared plus 3x plus 2x plus 6. And then when we add those like terms, we'd have x squared plus 5x plus 6. All right, so what we're going to be doing on this lesson is starting with this 3 terms and getting back to here. We're doing the reverse of FOIL. So this expression is called a trinomial. There's 3 terms, and it's a quadratic trinomial. All right, so a quadratic is something, and I'll write that, it's also a quadratic. Trinomial means 3 terms. Quadratic is an expression whose highest power is 2. So if you notice, the highest power here is 2. That's what makes it a quadratic. A quadratic can have 1, 2, or 3 terms. So a quadratic with 1 term would just be something like 2x squared. Okay, it's 1 term because they're not separated by, terms are separated by addition and subtraction, and the highest power of x is 2. Something with 2 terms would be something like 3x squared minus 8, or we could say negative 2x squared plus 7x. So here there's 2 terms because they're separated by addition and subtraction, and the highest power of x is 2. Same thing with this. There's 2 terms because it's separated by addition, and the highest power of x is 2. And then a quadratic with 3 terms would look something like up here. X squared plus 5x plus 6. There's 3 terms because there's plus signs here. 1 term, 2 terms, 3 terms. Highest power of x is a 2. We could do negative 7x squared minus 5x plus 10. Still a quadratic. Highest power of x is 2. So what we now know is we're going to, if we started out with x squared plus 5x plus 6, we can then factor it into x plus 2 times x plus 3, kind of work backwards. This is now factored because it's separated by multiplication. All right, and the way we're going to do this is with what we call the SAM method of factoring. And if we look at our flowchart, we're still looking for a GCF first always, but if we have 3 terms and the coefficient, remember coefficient means number in front of, you might want to make a note of that, number in front of the x squared equals 1, we can use this SAM method of factoring. We'll get to this bubble next lesson. So what does the SAM method of factoring say? It says, once you already look for a GCF and you see that you have 3 terms and that coefficient x squared is 1, the number in front of the x squared is 1, you're going to make 2 sets of parentheses that are being multiplied together. That's what's making it factored, because they're multiplied together. And you're saying what times itself is x squared. That's kind of the F part of FOIL, because remember we're doing reverse FOIL. We're then going to say what multiplies to the last term and adds to the middle term. And that's where the A and the M are going to come from. And then you can check your answer using FOIL. So if we look at this trinomial here, quadratic trinomial, okay, and we kind of look at our flow chart. First thing we want to look for is a GCF, and then if we have 3 terms with the number in front, we SAM factor that. Well, there's no GCF here, okay, because there's no x for this one, and there's no number, just a 1 here. So there's no number or variable that goes in every single term. There's 3 terms with a 1 in front, so we know we're going to do SAM. So notice how the S is over that first term, the A is over the middle term, and the M is over the third term. So what does that acronym stand for? S stands for single x squared. So you kind of have single meaning a 1 in front and x squared there. And then we have the A and the M. A stands for adds, M stands for multiplies. So once we see that single x squared term, we're looking for something that multiplies to 8, so this multiplies the last term, and adds to 6. So let's go ahead and work this out. So again, first step, I made my 2 sets of parentheses. What multiplies to x squared, x times x. And now we're saying what multiplies to 8. You always want to find the factors first, and then you figure out what it adds to second. So the things that multiply 8 are 1 times 8 and 2 times 4. So what we're trying to do is figure out a combination that we could get them to add or subtract to 6. Well, if I look at 1 and 8, if I add 1 and 8, I get 9. If I subtract them, I get 7, not the 6 I need. If I add 2 and 4, I get 6. So that means it's going to be 2 and 4, and I want them to be multiplied to be positive and add to be positive as well. So the way I can get them to do that is if they're both positive. 2 times 4 is 8, and 2 plus 4 is positive 6. So this is now the factored form. If we look at some more examples here. Again, looking at your flowchart, you always want to look for a GCF first. There's no GCF here. And then once we see that, there's 3 terms in that problem, and there's a coefficient of 1. Number in front is x squared, so it says we're using SAM. So I can put an S, an A, and M over top of that. Remember, SAM means you make 2 sets of parentheses. What multiplies to x squared is x times x. And again, those directions are also here. Make 2 sets of parentheses. What times itself is x squared, we wrote x times x. And then what multiplies the last term and adds the middle term, which is what that A and the M stands for. So what multiplies to -6 and adds to -1, because there's really a 1 in front there. So what I do is I don't worry about the signs. I just think about what multiplies to 6. 1 times 6, 2 times 3. And what's the only variation that I can get to get 1? So if I did 1 plus 6, I got 7. And if I did 6 minus 1, I got 5. So that can't work. If I did 3 plus 2, I get 5. If I do 3 minus 2, I get 1. So I know it's going to have to be 2 and 3. And now I just have to figure out my signs. So it multiplies to be negative. And remember, the only way you can get things to multiply to be negative is if one sign is positive and one's negative. Because the negative times positive is negative. And then they have to add to be negative. So this is always going to be the sign of your larger one, your larger number. So my larger number, the 3, has to be negative. The smaller number has to be positive. 2 times negative 3 is negative 6, and negative 3 plus 2 is negative 1. And again, that is factored, and if you wanted to do a quick check with FOIL, you could. X times x is x squared. X times negative 3, negative 3x. 2 times x is positive 2x. 2 times 3 is negative 6. And when you add those like terms, x squared minus x minus 6, and that's what we started with. So now, if we look at a couple other examples, so far we've learned 3 different methods for factoring. We've learned GCF, difference of squares, and SAM. This is where the flowchart is really going to come into play. So if I have 5x squared minus 5x minus 10, okay, I'll keep that at the top. And I will use our flowchart here. I always look for a GCF first. Well, in this case, I do have a GCF. 5 goes into all of them. There's no variable that goes in all 3, but 5 does. So I'm going to pull out a GCF of 5 first. So remember, GCF, you put the number in front, 1 set of parentheses. So I have 3 terms in here to start, so I do need 3 terms inside my parentheses when I'm done. I'm going to divide each term by 5. And so when I do that, 5x squared divided by 5 is x squared. Negative 5x divided by 5 is negative 1x. And negative 10 divided by 5 is negative 2. And I'm not done though. I have to follow this flowchart all the way through. So now if I look inside my parentheses, I have 3 terms. So that takes me over here. And if I look directly in front of my x squared, there is really a 1 in front of that x squared. So that means the coefficient of x squared is 1. So now it says I need to look to see if I can SAM factor that. So I'm now going to write my acronym of SAM over top. I'm not going to lose my GCF. The GCF stays in front. And I follow my steps for SAM, making the 2 sets of parentheses, what multiplies to x squared, which is x times x. And now I'm saying what multiplies to negative 2 and adds to negative 1. So the only thing that multiplies to 2 is 1 and 2. So I know it's going to have to be 1 and 2. And again, it's multiplying to be negative, so I know 1 has to be positive, 1 has to be negative. And it has to add to be negative, so the larger one has to be negative. So the 2 has to be negative because that's larger. The smaller one has to be positive. Negative 2 times 1 is negative 2, and negative 2 plus 1 is negative 1. And now that is totally factored. So notice how that was a 2-step factoring problem. GCF first, I followed the flowchart, did a GCF, and then I still have to follow through and still did SAM. For example 4, one of the things you need to know is that you always need you can never have a negative leading coefficient. Leading coefficient means the number in front of the highest exponent. So you always want a positive leading coefficient. Make a note here. So, even though it looks like there's not a GCF, there's not like a number that goes in all 3. 1, remember, goes in all of them. And since we can't have a negative leading coefficient, we're going to pull out a GCF of negative 1. So I'm just going to write here, GCF equals negative 1. And so that means I put a negative 1 in front, 1 set of parentheses because it's GCF, and then I'm dividing everything by negative 1. So I have negative x squared divided by negative 1 is just positive x squared. 11x divided by negative 1 is negative 11x. And then negative 18 divided by negative 1 is positive 18. All right, so as I keep going down my flowchart, so I did pull out a GCF. I had 3 terms now. And if I look now, I do have a 1 in front of my x squared, so that means I'm doing SAM now. So the negative 1 stays in front. I have 2 sets of parentheses. I have x and x. Now I'm saying what multiplies 18 and adds to negative 11. So things that multiply to 18 are 1 and 18, 2 times 9, and 3 times 6. So the only combination of numbers that I can get to multiply to 18 and add to negative 11 is if they are both the same sign. That's how you get them to multiply to be both positive, both negative. But since they have to add to be negative, that means both the 2 and the 9 both have to be negative, because negative 2 times negative 9 is positive 18, and negative 2 minus 9 more is negative 11. So I am now totally factored. And the last one, again, look to factor out a GCF first. That's step 1. In this case, I do have a GCF. 3 goes into 3x squared. 3 also goes into 27. So 3 is going in front. Remember, GCF is just one set of parentheses. And since I had 2 terms to start, I'm going to have 2 terms inside. And I divide each term by 3. So 3x squared divided by 3 is x squared. Negative 27 divided by 3 is negative 9. I then look inside, I still have 2 terms. So looking at the flowchart, I have 2 terms, and it's either difference of squares, or you can't factor it any further. So let's see what we have. In this case, I do have 2 terms. They are being subtracted, and 9 is a perfect square, and so is x squared. So now I am going to do difference of squares as well. So the 3 stays in front. I want to make 2 sets of parentheses. And remember, difference of squares means you take the square root of the first term. So the square root of x squared is x. That goes in the front of each set of parentheses. I take the square root of 9, which is 3. And that goes as the second term for each set. And I have 1 positive and 1 negative. All right, I want you to try these classwork examples, and we'll go over them in class.